Hello, in this video I will go over the exam number 1 review. So this will just be kind of a guiding video to highlight some of the key elements of each problem. So beginning with this first problem, we have to construct a frequency distribution with 6 classes. The first step is always to compute the range. The range is the highest minus the lowest value, in this case 39. Then we divide by the desired number of classes, so we will divide 39 by 6, and this will determine the class width. That is 6.5, and we always round up to the next whole number, so we round to 7. In constructing the frequency distribution, we need the class limits, the class boundary limits. Here I went ahead and just added a column for the midpoints, the tally, and the frequencies. For the class limits, we always determine the lower limits first, beginning with the lowest value, 51. We add the class width 7 to get 58, and then continuously add 7 to generate the other lower limits. To get the first upper limit, subtract 1 from 58 to get 57, and then once again just keep adding the class width 7. 7 plus 57, 64, and just repeat that process until all the other upper limits are computed. The lower limits close the gap between the classes. To do this, we subtract 0.5 from the lower, add 0.5 to the upper for each class limit. For the midpoints, we add the lower and the upper. So if we add 51 and 57, that's 108. Divided by 2 is 54. And then once again, the midpoints are separated by the class width, which is 7. So if you add 54 plus 7, we get 61, and then we can just repeat that process for the other midpoints. To tally the data, we just have to determine which class each data value belongs to. So for example, 66 belongs to the third class, so we place a tally mark. 78 belongs to the fourth class, place a tally mark, and just complete that process. We find that the frequency for the first class is 3, for the second 8, for the third 13, for the fourth 12, for the fifth 3, and for the sixth class 1. To construct the histogram, we place the class boundary limits on the x-axis, frequency on the y-axis. Here I go by units of 2. And then for each class boundary limits, the width will be the class boundary limits. The height of the bar will be the frequency. So from 50.5 to 57.5, we have a height of 3. For 57.5 to 64.5, we have a height of 8. And then we just construct the rest of the bars. The bars must touch when constructing a histogram. For the frequency polygon, we place the midpoints on the x-axis. So we will place these midpoints on the x-axis from 54 to 89, and then we plot points. So 54 and 3 will be the first point that's plotted. So 54 we go up 3 units, 61 we go up 8 units. And you plot all the points, connect the points with straight lines, and remember all the midpoints are separated by 7, so we have to create 2 hypothetical midpoints. We subtract 7 from 54 to get 47 and anchor this first point to the x-axis, and we do something similarly on the right side. We add 7 to 89 and get 96, and we anchor our last point to the x-axis at 96. That's the frequency polygon. Next, we have to construct a cumulative frequency. To do this, we list all the class boundary limits in the first column, and then to find our cumulative frequencies, well, we ask ourselves, what's the sum of all the frequencies that precede this first limit? There are no frequencies that precede the first lower class boundary limit, so we start with 0, and this is true for all cumulative frequencies. We next move on to the second class boundary limit, and 3 is the frequency that precedes that second class boundary limit. And then the third class boundary limit, the frequencies that precede it are 3 and 8. So we add 3 and 8 to get 11. And so that's how we have 0, then 3, then 11, and then we add 13 to get 24, and so on, until we compute all the cumulative frequencies. We use the cumulative frequency distribution to construct the ogive. We place the class boundary limits on the x-axis, cumulative frequencies on the y-axis. In this case, I go by units of 5. We plot the points. 50.5 at 0, 57.5 it's 3, and so on. And then we connect all the points with straight lines. And that is the graph for the ogive. Number 2, we have to find the mean, median, mid-range, and mode for a given set of data values. The mean is the sum of all the values, which is 219, divided by the number of values, 15. That's equal to 14.6. The mid-range is the highest plus the lowest value, so 23 plus 7 is 30, divided by 2 is 15. To find the median, we have to put all the numbers in order. In this case, since we have an odd number of values, the middle value is the median, which is 15. Finally, the mode is the data value with the highest frequency or has the most repetitions. In this case, it has to be 17. It has a frequency of 3, so it repeats 3 times, more so than the other data values. The third example, we have to find the mean, variance, standard deviation for group data along with the modal class. To find those values, we have to add 3 columns. We need to find the midpoint column. Remember, we just add 11 and 15. That's 26 divided by 2 is 13. The class width is 5, so we can simply add 5 to 13 to get 18. 5 to 18 to get 23, and we can repeat that process for the other midpoints. Next, we multiply each frequency with each midpoint. So 3 times 13 is 39, 5 times 18 is 90, etc. And then to find this last column, it's a little tricky. Remember, only the midpoints are being squared, not the frequency. So the best method to calculate this last column is to multiply each value in the midpoint column with the frequency times, or the values in the frequency times midpoint column. So 13 multiplied with 39 is 507, 18 multiplied with 90 is 1620, etc. Next, we find the following sum. So the sum of the frequencies is n is 40. The sum of the f times xm column is 1035, and the sum of the f times xm squared column is 28,575. To calculate the mean, we take the sum of the f times xm column, 1035, divided by n, which is 40, to get 25.9. To compute the variance, we use our variance for group data formula. It's n times the sum of the f times xm squared column minus the sum of f times xm quantity squared. So we have 40 times 28,575 minus 1,035 squared, all divided by n times n minus 1, or 40 times 40 minus 1. So multiplying this out in the numerator leads to 71,775. The denominator is 40 times 39, 1560. We divide to get 76. To get the standard deviation, take the square root of 76, and that's going to give us 6.8. Number 4, we have to find the weighted mean of the cost. To compute that value, the x values are represented by the cost, since we're trying to find this average. The numbered sold are the weights, so we have to multiply each data value with each weight. So 9 times 427,000 is 3,843,000. 6 times 365,000 is 2,190,000, and just repeat that process. We then find the sum of the weights, 27. The sum of the products, 14,733,000. Divide the sum of the products by the sum of the weights, and that's going to give us 545,666. Wait, $545,666.67. That's going to be the weighted mean price. Now, to compute the variance and standard deviation, the easy route is to take this information and input it into Microsoft Excel or your calculator to derive the values. Here I went ahead and worked it out using the formula, the shortcut formula. Using the shortcut formula, we list all the x values, find the sum, 2,049. We square each x value, find the sum, 604,335. And then n is 8. 8 is the number of values. And we plug this into our variance formula. The variance formula is n times the sum of the x squared column minus the sum of the x column squared divided by n times n minus 1. Well, that's going to be 8 times 604,335 minus 2,049 squared, all divided by 8 times 8 minus 1. We perform the computations to get 636,279 divided by 56, which is 11,362.13. Take the square root of that to get 106.6 for the standard deviation. The variance is 11,362.13. For this next problem, we have to construct a pie graph. In this case, we're given percents. To find the degrees, we multiply each percent by 360, and that's going to give us the degrees of each section in the pie graph. Next, we use our degrees to construct the sections. You can also use percents if you want, and we label each section according to the percent and the category name, and the pie graph should have a similar shape to this. For our next problem, we're drawing a Pareto chart. So Pareto chart is a bar graph in which the bars have been arranged from highest to lowest. So the data here has already been arranged in that manner. All we do is we put the category names on the x-axis, frequencies on the y-axis. The first bar has a height of 28, second has a height of 18, etc. And then we can then analyze the graph to see which are the two favorites. In this case, it's mobile and ARC. For the stem leaf graph, we have to split each data value into a leaf and into a stem. The leaf will be the last digit. The stem are the digits that precede it. So the lowest value in this problem is 12. So we split 12 as stem 1, leaf 2. The largest value is 67. So we split 67 as the stem will be 6 and the leaf is 7. And so for the stems, we list all the numbers from 1 to 6. And then for the leaves, we list the values. In this case, I use commas, but if you're working with Connect Math, do not put commas between the values. Leave the commas out of the answer. So if we were to take all the numbers at stem 1, so for example 12, we would write that as 1 2. There's another 12, that's written as 1 with another 2, And then 14, we just add a 4 at the end. So our first set of numbers with stem 1 would be a 1 followed with 2, 2, and 4. And then repeat that pattern for the other stems. So number 9, we're given a set of data. We have to find the data value in the 40th percentile and then the percentile rank of 350. Step 1 is we put all the values in ascending order. If we are given a percentile and we have to find the data value, there's a formula that we need to use. It's C equal to NP over 100. N is 7 because there's 7 data values. P is 40 for the percentile. So 7 times 40 is 100. 280 over 100 is 2.8. We round 2.8 up to 3, and then we count 3 spaces to get to our answer. So 1, 2, 3. 430 is in the 40th percentile. For part B, we have a formula to compute the percentile. It's the number of values below 350 plus, so we'll say below, the value, or the precede the value, in this case 350, plus 0.5 over n times 100. So how many values precede 350? Well, there's only one. So it's 1 plus 0.5 divided by, we have 7 values, times 100. So that's 1.5 over 7, which rounds to 21.42857 after we multiply by 100. And then we ultimately round this to 21 using regular rounding rules. So P is the 21st percentile. For the next problem, we have to find quartile 1, 2, and 3 along with IQR. First step, we put everything in order, ascending order from lowest to highest. Quartile 2 is the midpoint of all the data values. Since we have an odd number of data values, the overall midpoint is 15. So Q2 is 15. Now we look at all the data values that precede 15, and we find the median of those values. So this is the median, sorry. We're looking for the median. Q2 is the median of the data set, 15. Now we have to find the median of the values that precede it. Since we have an even number of values, we have to compute the midpoint of the 9 and 10. So 9 plus 10 is 19 over 2, 9.5. That's Q1. To find Q3, we have to find the median of all the values that follow Q2. So there's 4 values. We find the midpoint of the 2 middle values, 21 and 22 divided by 2 is 21.5. So IQR is Q3 minus Q1, so we take 21.5 minus 9.5 to get 12. Now we also want to check to see if there's an outlier, right? So to determine if there's any outliers, we have to compute the left fence, that's Q1 minus 1.5 times IQR, so 9.5 minus 1.5. You think of this asterisk as representing multiplication, times 12, it's negative 8.5. For the right fence, it's Q3 plus 1.5 times IQR is 21.5 plus 1.5 times 12. That's 39.5. And if we look at our data values, the left fence is out in this area here, so there's no outliers on the left side. But 39.5 is a fence that is between 22 and 78. So 78 is outside our fence. Thus, 78 is an outlier. And then just in summary, Q1 is 9.5, Q2 is 15, Q3 is 21.5, IQR is 12, left fence negative 8.5, right fence 39.5, and yes, there is an outlier, it is 78. And that's just kind of a cursory view of the answers for review number 2. Always inbox me if you have any more questions. Thanks for watching the video.